Hey everyone, Dr. Mungli here. So in this particular video, I will be explaining you a type of fatty acid oxidation called omega oxidation. Now what is this omega oxidation, in which tissue this omega oxidation is going on, and at what conditions omega oxidation is going on in our body, all this I am going to explain in this particular video. Now what is omega oxidation? If you take a look at the fatty acid, so fatty acid has got a carboxyl end and it has got a methyl end. So in a classic numbering of fatty acid, so we start numbering these carbons as a carbon 1, carbon 2 and like that we just go on. And we also can number fatty acid from starting from the methyl end, and that is we refer this methyl carbon as omega 1 carbon, and then we come back towards the carboxyl side as omega 2 and all the way towards this side. So that means this is the omega end, methyl end of a carbon is a omega end. Now in omega oxidation what happens? So the most of the time, so in omega oxidation there will be oxidation of this methyl group here. So where exactly omega oxidation is going on in our cells? So the omega oxidation is predominantly going on in the liver and also to a certain extent in the kidney, and in the liver and kidney endoplasmic reticulum, especially smooth endoplasmic reticulum is the one which will conduct omega oxidation done by a special enzymes called cytochrome P450 class of enzymes. These cytochrome P450 class of enzymes which are present in the smooth endoplasmic reticulum, so what they will do, they are going to oxidize the methyl carbon here and thereby they will make dicarboxylic acids. Let me show you how that happens. So this fatty acid here with the methyl end, that is CH3, so that methyl carbon, it will be converted into hydroxyl group. So this particular methyl carbon here, so it will be converted into CH2OH, that is the hydroxyl group. So this job it will be going on in the smooth endoplasmic reticulum. So if I need to rewrite this particular fatty acid, so it will be looking something like this. So it has got a hydroxyl group now. So methyl group is now converted into hydroxyl group. Now furthermore, so one more oxidation going on here. So the hydroxyl group it will be converted to keto group. So it will be C double bond O, that is CH double bond O, and it will be CH2 here, then CH2 N number, and then CH2, and we have COO minus. Now furthermore, this particular fatty acid will undergo oxidation, so we have COO minus, CH2, then CH2 N number of times, then we have CH2, C double bond O and O here, that is COO minus, that is the COO minus. So basically we got this fatty acid at the end of oxidation. So the methyl and CH3 is initially converted to hydroxyl group CH2OH, so that is alcohol, and then we have keto group C double bond O, and then we have C double bond O and O. So basically that's a carboxylic group. So it means at the end of omega oxidation, you have a fatty acid with the two carboxyl group. This is one carboxyl group, COO minus, and this is another carboxyl group, another COO minus. That means this is a dicarboxylic acid. Dicarboxylic acid. This is the product of omega oxidation. So in the omega oxidation going on in the endoplasmic reticulum, so a fatty acid is converted into dicarboxylic acid. Why this happens? So if you look at, say, if this is a long chain fatty acid, long chain fatty acids are not soluble in the water that's in the blood. So because it has got only one carboxylic group here, so because that's an anion here, so all the other thing is hydrophobic. Now if you convert this fatty acid into dicarboxylic acid, you have two carboxylate group. So that means you have COO minus one negative charge and another COO minus here. So that will increase the solubility of this particular fatty acid. So dicarboxylic acids are more soluble, and these dicarboxylic acids, they can undergo beta oxidation or they can be secreted out of the cell, out of the endoplasmic reticulum into the cytoplasm. From there they will come out of the cell and they can be filtered out of the blood into the urine because these are soluble molecules because of 2-carboxylic group. Dicarboxylic acids are water soluble and they can be easily filtered out of our body. Now, when do you see omega oxidation going on predominantly? So, whenever there is a saturation in the beta oxidation process in the mitochondria where fatty acids are undergoing beta oxidation, when there is a saturation of beta oxidation, or whenever there is a defect in the beta oxidation, say one or the other enzymes participating in beta oxidation, if they are defective, like MCAT deficiency, medium chain acyl CoA dehydrogenase deficiency, or SCAT deficiency, short chain acyl CoA dehydrogenase, or LCAT deficiency, long chain acyl CoA dehydrogenase deficiency, or there is a carnitine deficiency, primary carnitine deficiency, or there can be deficiency of carnitine palmityl transferase 1, carnitine palmityl transferase 2. In any of these deficiencies where there is a decrease in beta oxidation going on, during that time fatty acids are diverted from mitochondria into the endoplasmic reticulum, and in the endoplasmic reticulum, so these fatty acids, they will undergo omega oxidation where the omega carbon, that is the methyl group, is converted to carboxylic group. Thereby you have 2 carboxylic groups here, making that fatty acid more water soluble, and you get the dicarboxylic acid. The presence of dicarboxylic acids, increased levels of dicarboxylic acids in the blood or in the urine, it is one of the indication for a defect in beta oxidation, and this defect in beta oxidation can be because of variety of causes as I explained before. So this is what is omega oxidation. So all you need to remember is omega oxidation will be going on predominantly in the endoplasmic reticulum, and that happens whenever there is a defect in the beta oxidation process, or if there is a defect in the carnitine shuttle mechanism, especially for long chain fatty acids. Okay, so you will see elevated levels of dicarboxylic acid. Depending on which type of dicarboxylic acids are elevated in the blood or in the urine, that will give you the diagnosis. Like in MCAT deficiency, so there will be medium chain dicarboxylic acids elevated. That means dicarboxylic acids will have number of carbons between C6 to C12. That kind of dicarboxylic acids are elevated. If there is a short chain short chain acyl CoA dehydrogenase deficiency, there will be dicarboxylic acids with less than 6 carbons being elevated in the blood. If there is a long chain acyl CoA dehydrogenase deficiency, there will be accumulation of 13 to 21 carbon dicarboxylic acids can be elevated in LCAT deficiency. Or if there is a carnitine deficiency, primary carnitine deficiency, or maybe acquired carnitine deficiency, or CPT1 deficiency, CPT2 deficiency, during that time also long chain dicarboxylic acids will be elevated in the blood and they can appear in the urine. So that means whenever there is a defect in the beta oxidation process or decreased beta oxidation, you will see omega oxidation going on in the endoplasmic reticulum. This is an alternate way for our body to get rid of the excess fatty acids in the urine in the form of dicarboxylic acids. This is all about omega oxidation. I hope this video has helped you in understanding omega oxidation, where it is going on and what is the importance of omega oxidation. So thanks for watching, and make sure to click subscription button down there so that you get regular updates whenever I make videos on biochemistry topics. And see you in my next video. Till then, you take care.
Let's go! Party rock is in the house tonight. Everybody just have a good time. And we gon' make you lose your mind. Everybody just have a good time.